Enumerations. You may recall that back in the example where we presented the craps dice program, we introduced the basic concept of an enumerated type. We had created an enumeration called status that represented the states of our game and helped us determine when we won, lost, or needed to continue rolling the dice. Well, now we're going to look at enumerations in more depth. The concept of enumerations was introduced to Java back in the Java Standard Edition 5. The current version of Java is Standard Edition 6, and the next version, Standard Edition 7, is currently under development. That one is codenamed Dolphin. Now, when this was introduced, they actually provided a much more robust concept of creating an enumerated type, a set of constants, than what we have in most other programming languages. For example, in C and C++, an enumeration is only allowed to contain integral values, integers, shorts, long values. It cannot contain anything else. But the enumerated type concept in Java is actually quite robust. Each enumerated constant is actually an object of the enumerated type, and each of those objects may contain data and may have methods that we can use to obtain the values of those constant data values. So a couple of key things that you need to know about with enumerations. We've already introduced the fact that enum is the keyword that we use to introduce an enumeration. And we also saw that inside of the enumeration's curly braces, we provided a comma-separated list of enumeration constants. So we've already covered those issues, and we'll see that again in our example momentarily. Also, there's a couple of other things that you need to know about enumerations. First of all, enumerated types are implicitly final. What that means is you cannot use them in this context called inheritance, which is a key concept in the second of this two-course video sequence. If in fact you are able to inherit from a class, that means that you're also able to do things like redefine the capabilities that you inherit. For example, we can redefine the capabilities of the toString method to make them specific to any new class that we define. This is not the case with enumerated types. Whatever you define is constant and final. It cannot be inherited from, and it cannot be redefined. Separately, enumeration constants are implicitly static. Because they're constants and they can never change, there's no reason to allow multiple copies of them, so the compiler automatically makes them static members of the enumerated type. And finally, it is actually a compiler error to attempt to create an object of one of your enumerated types. And again, that has to do with the fact that all of the members of the enumerated type are implicitly static members. There's one copy of each constant, and that's it. A couple of other key things about enumerations. You can use an enumerated constant anywhere a regular constant can be used. So for example, in a switch statement, you can have cases that use enumerated constant values. And also, enumerations can have constructors, which we'll show you in the next example. And just like any other class, you can specify parameters to those constructors and overload those constructors as well. A few other things that you need to know about enumerations, and we're going to demonstrate these concepts in the next example also. First of all, every enumeration gets a method named values automatically generated by the compiler, and what that method does is it returns to you an array of all the enumeration constants in the same order that you declared them in the enumerated type definition. And then finally, there's another class called enum7 for manipulating ranges of elements, among other things, inside of an enumerated type. So for example, if you have a large enumerated type with 10 different constants in it, you may want to process just a subset of that range of constant values, and you can use the range method, which is a static method of class enum7, to specify the range of elements you wish to manipulate, and then to get back something that can be iterated over via the enhanced for statement. So it will automatically figure out how many constants were returned and touch every constant, allowing you to manipulate that constant value. So let's go ahead and take a look at an example of this. We have in this next example two figures. Figure 8.10 book.java is our new enumerated type, which you can see here defined at line 5. And then we have a separate file, enum test.java, where we'll test out the enumerated type capability. Now, just like we did when we introduced the status enumeration back in the craps class, the very first thing you do inside the curly braces of your enumerated type is specify a comma separated list of all your enumeration constants. So we have 1, 2, 3, 4, 5, 6 different constants in this case, and each of the constants in this book enumeration actually represents one of our textbooks that we've written in the past, and it has two pieces for every one of the constants: the title of the book and the copyright year of the book. Now, normally when you have constant values in enumerations in other languages, it's just a single value, which is an integer. Here you can see that we're actually supplying more robust information as the values of our constants. Notice that all of the constants are named with all capital letters as a convention. That helps them stand out in the program. And what you're actually seeing here are constructor calls for each of these constants that allow us to initialize the two pieces of data that are going to be stored in each of these constant objects. And by the way, each of these constants is actually an object of type book that we are defining. And the objects are created for us automatically. We can't create them using the new operator. Now, each of our enumerated constants is going to have in it two pieces of data, a string called title and a string called copyright year. By the way, it's a syntax error if you put any code in your enumeration data type before the actual constants are declared. So you have to put your instance variable definitions after the set of constants. Notice that both of them are final. That's because these are enumerated constants. They can't be modified after they're initialized. So the instance variables have to be final. And that is Java's version of the const keyword that you have in many other programming languages. Our constructor for each enumerated constant is this book constructor that receives the title and the copyright year and assigns them to the appropriate instance variables. And just like any other class, you can have methods in your enumerated type. We only have get methods because you cannot modify the constants after you initialize them. So the get methods enable us to retrieve the title for one constant and the copyright year for one constant, respectively. So let's see how we can use this in a program. First, we wanted to demonstrate to you that you can iterate over all of the different constant values in an enumeration. And for that purpose, in the enum set class, we've got a for loop, an enhanced for loop, that says we want to pick off every book in whatever is returned by this book.values method call. Now again, the values method we didn't define. It's a static method of class book that's automatically generated for us, and it gives us back an array of all the enumeration's constants. So that means we're going to get back an array with these 6 constants in it in the exact order that you see them here in lines 8 through 13. Now, each of the array elements, one at a time, will be assigned to the book control variable, and then we have a little printf statement here that's going to take the book object and we're going to output it in string format to show you that there's a built-in string representation, and then we're also going to output the title and the copyright year as strings as well, and for that purpose we're going to call book.getTitle and book.getCopyright year for each of the book objects we get back. Now separately, we have another enhanced for statement down here at lines 19 through 21 that takes advantage of another class called enum set. You can see that class imported here at line 3. It's part of the java.util package. And the enum set provides the method called range, which you see here on line 19. It's a static method of class enum set. And you give it a range of constants that represents the set of values you'd like to iterate over. So let's go back and take a look at our constants once again. We have JHTP6 through C# HTP as our 6 values. Back here we want to go from JHTP6 through CPP HTP4. So once again, here's JHTP6, here's CPP HTP4. So we want to iterate over these 4 elements rather than all 6. So what the range method does is it gives us back something that we can iterate over that contains only the constants from JHTP6 to CPP-HTP4, and we're going to output the same information once again: the string representation of the particular constant, the title of the particular constant, and the copyright year of the particular constant. Let's go ahead and run our program so we can see the program's output. Okay, and if we scroll down a bit here, you can see that in the first loop we were able to iterate over all of the different values. The toString for an enumerated constant automatically gives you back the name of the constant, and then we picked off the title and the copyright year ourselves using our get methods, and you can see all 6 values were done. And then separately down here we have the 4 elements that we iterated over as a result of using the enum sets range method. So you can get a sense here that the concept of enumerations is much more robust here in the Java programming language than what you may have seen in some other programming languages.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons, self-paced personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.